Hello everyone, hope you are fine. So today we are going to start a new chapter in IGCSE Block 1, General Physics, and in that the chapter 2, describing motion we are going to take. Okay, so in this chapter it is mainly included the main concepts of motion. Okay, so motion, it consists of so many topics. So these are the topics we will explain in this chapter. So let's see. So, in this chapter, the first topic it is how to calculate speed and average speed. That is the first topic of this chapter. You know, my dear students, you already know about speed. You already learned that topic in your previous year. So, what do you mean by speed? If you know the distance and time, we can easily find the speed mathematically. Okay, so what is the equation of speed? From your junior classes, you already started to learn about that. So the speed can be defined as the distance over time. So distance traveled by an object with respect to time, it gives the magnitude of speed. Okay, and what is the SI unit of speed? The speed SI unit is meter. What is SI unit? The system of international or international system of unit. That is meter per second. So the international unit of speed is meter per second. And here is the equation. Speed is equal to distance traveled per unit time. Okay? Yes. So the next topic is average speed. Do you know, my dear students, in which situation we have to find average speed? If a body is traveling in non-steady speed, if a body is traveling in non-constant, that means the speed is not constant. In such a situation, we have to calculate its average speed. Suppose a body is traveling in different speed. Sometimes speed is increasing and sometimes speed is decreasing. Okay, in such a situation, we can only find the average speed. We cannot find the value of speed accurately. So in such a situation, the average speed we have to find at the end of the journey. And that is only possible at the end of the journey, only we can find the average speed. And what is the equation? That is total distance traveled by the object divided by total time taken. This is the mathematical equation to find average speed. And one more thing, don't forget, my dear students, this average value or average speed we can only find at the end of the journey. You already know about the speedometer, which we can see in vehicles. And it displays the instant speed of an object. It is not average speed. Instantly, that means while traveling, we can see in which speed we are traveling. So for that case, we are using the speedometer. So speedometer, it can only show the instant speed or instantaneous speed. But here, the average speed we have to find manually by using the equation total distance traveled over total time taken. And the unit of both speed as well as average speed is the same, that is nothing but meter per second. Hope you understood that. Okay? Yes. So, while doing the numericals or the problems, we should aware about the unit system, the units. Because here in this chapter, we are about to learn some physical quantities. We already learned one physical quantity, that was speed. Apart from that, some more physical quantities you have to learn. So let me introduce distance. You already know about distance, no need to define further. Distance is the total length of the path traveled by the body. Definitely we need a path for a journey, am I right? Yes. To travel from one place to another, we need a path. So the total length of path traveled by a body, that is what called distance. Okay? So you know that. And what is the SI unit of distance? That is meter. Meter is the SI unit of distance, but apart from that, we have to learn some other units also, like kilometer, that can be represented by the letter km, both should be small, and miles also can be used. So the SI unit is only meter, and m can be used for the denotation. And the next is time. No need to explain further about time. You already know there are several measuring instruments. By using them, we can easily find the time. So the unit is second, that is the SI unit. Second is the SI unit to measure time. Apart from that, hour we can use, or minutes also we can use. Or milliseconds, microseconds, like that also we can use. So those conversions are very very important. So that I will introduce during doing a problem or something. Okay. Yes. The next is speed. As I told, the SI unit of speed is meter per second. But apart from that, we can use kilometer per hour also. So the conversion is very very important. How to convert from one system of unit to another system of unit. That means, let me say you one example. Meter per second, how can be converted to kilometer per hour? And kilometer per hour, how can be converted to meter per second? Very important. While doing the problems also, you should learn thoroughly about the unit conversion. It is very very important, my dear students. So meter per second, here I am writing. Okay, meter per second can be converted to kilometer per hour. How can we convert that? There is an easy method. Meter per second, if you want to convert the meter per second to kilometer per hour, you have to multiply that value with 18 by 5. Clear? 18 by 5. So meter per second, suppose if the value is given in meter per second, that can be converted to kilometer per hour by multiplying that value with 18 by 5. Do you want to do an example? Yes. Suppose 5 meter per second, value is 5 meter per second, and you want to convert that to kilometer per hour. What is the corresponding kilometer per hour? 5 meter per second, then we have to multiply with 18 by 5. So both 5 will cancel, 5s will cancel, and we will get 18 kilometer per hour. So my dear students, 5 meter per second is corresponding to 18 kilometer per hour. That is the conversion. Hope you understood that. So, what will be the reverse process? How can we convert from kilometer per hour to meter per second? Just multiply with the reciprocal of this value. That is 5 by 18. You have to multiply this value with 5 by 18. Let me show it. Here, suppose the value it is in 18 kilometer per hour. 18 kilometer per hour is the value. So how can we convert this value to meter per second? Simply by multiplying with 5 by 18. Clear? Yes. So 18 and 18 both will cancel, and finally we will get 5 meter per second. What an easy conversion. Okay? So easily we can convert. So the conversion of each unit system, it is very very important while doing these problems. Okay? Hope you understood, my dear students. So you should know about all the unit system. It is very important while doing the numericals, the unit system, how to convert from one to another form. You can either use your calculator, or without calculator even also you can find the answers very easily, my dear students. So what is the next concept? Listen, I think you are familiar with this topic. In the last year, that means in year 8 science, if you studied the essential science, I think most of the syllabus you can see the topic. That is, this is what called a light gate. You can see this. This is the light gate. Okay? The light gate, this is the single light gate. Here we are using single light gate, and here we are using 2 light gates. Okay? So what is the function of light gates? Light gate is an instrument, and there are some kind of the light radiation, that is infrared ray. You are familiar with the infrared ray that usually we can see in the remote control. We are using infrared ray, which is invisible to us. We cannot see that. So that infrared rays is using in this light gate. This is the light gate, and this is infrared light ray. It is passing through the gate. So what is the purpose of this light gates? By using light gates, we can measure the speed electronically. We already studied the method to find speed, that is total distance divided by total time taken. That is the equation which we can use to find speed. But it might not be accurate every time. Every time it might not be accurate. So we need an accurate value. So for that purpose, we can use some electronic equipments, and light gate is one of the familiar, that is one of the famous one. We can use them. So this is the single light gate, and here we are using 2 light gates. So what is the difference? First of all, let me start with the single light gate. So we can see that the vehicle is passing, and here we are using one interrupt car for this experiment. This is only we are doing in laboratory. So to make it convenience, we are using one interrupt car. So how it works? Let's see. Here you can see the explanation. Let me read that. The leading edge of the interrupting card. This is the leading edge. Start. This is the leading edge. And the leading edge, what will happen? That means that the leading edge of the interrupt card that first will break the infrared rays when it pass through the light gauge. At that time, what happened? The leading edge, that is the start point of the card, it break the infrared. So when it break the infrared light, at that time here the timer, it is connected to the timer and the timer will start. Okay, the timer will start once the leading edge of the interrupt card, it breaks the infrared. And once it's completely passed, at that time what happened? The infrared again it make join. That break will move and it will join again. At that time what will happen? The infrared light ray, it will stop. Sorry, not infrared ray, but the timer will stop. Okay, so the infrared, it will break because of the interrupt card, and once it's rejoined, at that time the timer, what will happen? It will stop. So it will give the instant time, the instantaneous time that taken by the vehicle to pass through the breaker or pass through the light gate, it will measure. So the time we will get electronically with the help of light gates. So time is getting with the help of light gates. And what about distance? We need distance also now to measure speed. Which are the two physical quantities we need? Distance and time definitely. So time we are getting from the light gates. And what about the distance? Distance we will easily get by measuring the length of the interrupt card. Am I right or wrong? Yes, by measuring the length of the interrupt card, we can easily obtain the value of distance. So, easily we can use the equation. So, time that is getting by light gauge and distance is getting from the interrupt card. Here I am using the arrow mark. So, then we can find the speed. That is, and that also can be done with the help of electrical or some computers are connecting with this timer. So, they will automatically convert the value to speed. And we can easily obtain the value of speed. Then what is the difference from there to here? That means here we can see two light gates are using, my dear students. Two light gates. So the first light gate, what they will do? They will start the timer. Once the vehicle passes through, here we are not using the interrupt card, but instead of that there is a peg brake infrared beam. A peg we are using here. This is the peg that we are using in this vehicle. So the peg, what will happen? The first it passes through the first light gate, and that helps to start the timer. And once it passes through the second one, then suddenly what happened? The same timer will stop also. So the timer will start when it passes through the first light gate, and the timer will stop when it passes through the second light gate. So definitely they will get the time with the help of timer. Again they are getting time with the help of timer. So what is the difference between these both? Here they are using the interrupt card, but here without interrupt card they are only using a peg, a log or a wooden log or something they are using. Experimentally they are using in the lab. So by using that they can easily find the time. So don't forget, my dear students, in both cases we are using the light gauge to measure time. But the difference is, in the first case we use the interrupt card, and in the second case we are not using the interrupt card, but instead of that we are using two light gates. So time we are getting. So by getting time we got. Next what we need the distance. But here we are not using the interrupt card. Then how will we get the time? Sorry, distance. So distance we can measure by measuring the distance between the consecutive light gates. The consecutive light gates. This is the first light gate and this is the second light gate. So the distance between the two light gates gives the distance. So distance we got here, and time also we are getting with the help of timer, my dear students. So distance and time both we got, and easily we can find the value of speed also. That also will be done with the help of a computer. So my dear students, by using these electronic gadgets, we can easily find the value of speed. It is not only easy but also accurate value you will get. Hope you understood, my dear students. So coming to the next session. So here the next topic of this chapter is distance time graph. Motion can be represented with the help of graphs. So what is the purpose of graph, my dear students? Graph, we usually see somewhere the graphs they are using. So what is the usage of graph? Graphs helps to convey the information so easy. The graph, with the help of a graph, while IPL or something, the while cricket at that time also you can see the score rate. Either you can see the score rate directly or with the help of some graphs, it will show the status. What is the current status of each team? That can be easily understood with the help of graph, the line graph we are using. So in the case of motion also, we can use graphs. Okay. So basically you have to learn two types of graphs in this chapter. The first type of graph is called a distance time graph. Okay. So what is the speciality of distance time graph? Please listen. As per all the graphs, as like all the graphs, here also it has two coordinates. You can see a graph consists of two coordinates or two axes, x-axis and a y-axis. So we used to represent time in x-axis. So time, the physical quantity time, we can represent in x-axis. This is the x-axis, and then in y-axis we can represent the distance. Okay, usually we are doing like this. Time, it is representing in the x-axis. It may either in second or minute or in hour, that as your wish. And the distance, that can be represented in y-axis. Okay? Yes. So here you can see the nature of the nature of motion. That means what type of motion the object is implementing. That we can easily conclude with the help of the graph. That means with the help of by observing the nature of graph, we can understand what type of motion the body is implementing. Let's see. Here first you can see stage A. Here in this graph you can see three different stages. Stage A, stage B and stage C. So look the first stage A. So what you can understand from stage A? Stage A here, the body, its distance and time both are changing uniformly. You can see that from 0 to 5 minutes, not second but minute. So from 0 to 5 minutes, the body is traveling uniformly, or that is also called steady speed or uniform speed. So you can see here, my dear students, from 0 minute to 5 minutes, the body, that means stage A, body is traveling in uniform speed. That means steady speed. Then what is happening from the minute 5 to 15 minutes? That means 10 minutes. The next 10 minutes, the first 5 minutes, it travels in steady speed. Then what is happening in the next 10 minutes? That means during stage B. During stage B, here also the body is implementing uniform motion. That means steady speed. Then what is the difference? You can see that here the line B is becoming more steeper than A. Am I right or wrong, my dear students? Yes. Here the line A and line B, you can compare both. Which one is more steeper? The more steeper is B. That means if the line is more steeper, that means the speed is higher. So we can say that speed during stage B is greater than speed during stage A. That is the difference. So the speed during stage B is, here I am writing it here, speed during B is greater than speed during A. Hope it's clear. In the last year, that means in year 8 also you learned the same topic. By using the graph, we can identify whether it is traveling in slow speed or high speed. That easily we can understand. If the line is more steeper, that means the speed is higher. If the line, it is the slope, if it is less, that means the less steeper, that means it is moving slowly. That is the difference. Okay, hope you understood that. So stage A, the body is traveling slowly but in steady speed. Then in stage B, body is still traveling in steady speed but the speed little bit increased. It is moving in high speed. And then during stage C, Look, dear students, what is happening? Look at that. What is happening during stage C? The speed is becoming constant. Sorry, speed is not becoming constant. The body is coming in rest. During C, you can see the distance is not changing. So what you can see during stage C, distance is not changing, only time is increasing. What is the meaning of it? Body is in stationary condition. That means it comes in rest. So A, steady speed with a slow speed. B, also steady speed with a high speed. And C, it is coming to rest. So in this way, we can easily understand or we can easily conclude the type of motion. Okay. So that is the speciality of distance time graph, my dear students. Okay, the same thing you can see here, the explanation. Okay. Yes. So I hope you understood the topic distance time graph. So let's come to the next topic. Okay, so here is the next topic, that is acceleration. Okay, but you should understand one thing, we only learned one type of graph, that was distance time graph that we completed. So one more graph we have to learn, but before that we should learn a new topic, that is acceleration, that related to motion. So what is acceleration, my dear students? Please listen. Here you have to understand, suppose there are so many cases that you already met. That means one example I will give you. Suppose a car, it is moving from rest, and after 10 seconds it obtain at speed of 10 miles per hour. After 10 seconds, you just imagine a car, it is starting from rest, and it obtain a speed of 10 miles per hour in 10 seconds. Okay, let me draw it, or let me write it once again. A car, okay, suppose it is starting from A and it's reached B. At the A, the speed was 0 miles per hour, and when it reached B, after 10 seconds, what happens? Its speed increases, or the speed obtained to 10 miles per hour. So 0 miles per hour, it converted to 10 miles per hour in 10 seconds. So what we observed in this situation? We observed a speed change. So how the speed change, or how the car, its speed increases? In each second, its speed is increasing by 1 miles per hour. Am I right or wrong? In each second, that means total 10 seconds time it took to obtain a speed of 10 miles per hour. What is the meaning of that? That means in each second it accelerates. That means it increases the speed by 1 miles per hour. That is the meaning of that. So that is what called acceleration. Simply we can say change in velocity that happens with respect to time. That is what called acceleration. So what is acceleration, my dear students? Change in velocity with respect to time. If velocity change or if speed change with respect to time, that is the condition of acceleration. So let me explain. It is the rate of change in speed or change in speed per unit time. That is what called acceleration. So acceleration can be defined as the rate of change in velocity. The rate of change in velocity means what? Change in velocity per unit time. That is what called acceleration. Okay, but one more thing you have to understand. Acceleration is a vector quantity. You already studied about two types of quantities, scalar and vector quantities. Acceleration is a vector quantity. That means it has direction. So we can modify this definition. It is the rate of change of speed. Instead of speed, we can use the term velocity. What is the difference between speed and velocity? What is the difference between speed and velocity? Speed, it is a scalar quantity. That means, scalar quantity means what? It only has magnitude, but there is no direction. But if we are adding the magnitude and direction of speed, then it becomes velocity. I will explain you once again. That means the speed with the direction is called velocity. If the speed Speed has a value, and that value, along with that value, we are adding the direction also. We are specifying the direction also. That is called the velocity. So it is the rate of change in speed. Instead of speed, we can consider velocity, or it can also be called as the change in velocity per unit area. Sorry, unit time. Change in velocity per unit time. So my dear students, what is the difference between velocity and speed? Speed is a scalar quantity, that means it has only magnitude, but velocity is a vector quantity, that means it has both magnitude and direction. Both are numerically same, but not every time. So that we will learn later. So if speed I am specifying with direction, suppose if I am explaining a car is traveling 5 meter per second towards north, that become magnitude and direction. That means it is becoming a vector quantity, that is called velocity. Or an aeroplane, it is moving towards north in some mile distance, either like 500 kilometer per hour or something like that. But the direction also, if I am specifying, then we can say it is velocity. So change in velocity with respect to time or per unit time, that is what called acceleration. And it is a vector quantity, as I said. And what is the SI unit of acceleration? Meter per second square. How we obtain that equation? Let's see. Acceleration. This is the equation of acceleration. Acceleration is equal to change in speed with the direction or change in velocity divided by time. So acceleration is equal to change in velocity divided by time. That is the equation. And here we are using its short form. Change in velocity, we can write it as V minus U by T. What is V? V represents final velocity. V represents final velocity. It is written here. V represents final velocity. And what U? U represents initial velocity. And finally, T represents time. So dear students, acceleration can be found out by using the equation change in velocity by time. That's, we can write it as in equation form V minus U by T. And what is the unit of speed or what is the unit of velocity? What is the difference between speed and velocity? Let me say it again. Speed with the direction is called velocity. Okay, speed with direction. Please note down the definition. Speed with direction is called velocity. Okay, don't forget it. So, velocity, the unit of velocity and speed both are equal. Okay, the unit of both speed and velocity, that is nothing but meter per second itself. So, change in velocity. What is the unit of velocity? It's meter per second by, what is the unit of time? That is also second. So, meter per second divided by second, it's together to form meter per second square. So, that's how we got this unit, meter per second square. Don't forget, my dear students. So what I told about acceleration. So what is acceleration? The rate of change in speed with direction, or also we can call it as the rate of change in velocity, which is called acceleration. So don't forget, if speed change, okay, if speed change, not actually speed but velocity. If velocity change with respect to time, we can call it as an acceleration, or acceleration is possessing in that object. That we can conclude. Okay, so here you have to understand, as I told, acceleration is a vector quantity. Vector quantity means it has direction. Direction means sometimes acceleration become positive value, sometimes acceleration become negative value, and sometimes acceleration becomes zero also. That means acceleration may be either positive, negative, or zero. Okay? Means acceleration is a vector quantity. That's why its direction is changing. So acceleration, it can be positive, it can be negative, or it can be zero. In which situation? Let me explain. If an object speed increase, if an object increase its speed, the speed is increasing with respect to time, we have to say the acceleration is positive. So acceleration become positive if the speed increase. So we can say the object is accelerating. Accelerating means what? Acceleration is becoming a positive value. At the same time, if an object slows down, we have to say the object is decelerating. This is the opposite term of accelerating. Accelerating means the acceleration is becoming a positive value, and decelerating means acceleration is getting a negative value. That is the difference, my dear students. So the negative acceleration is also called the deceleration. So during such a situation, acceleration is becoming a negative value, or acceleration is becoming negative. So acceleration is becoming positive if it speed up. If an object speed up, acceleration is becoming positive, and that is exactly called the acceleration. At the same time, if an object slows down, that means acceleration is getting negative, and their acceleration is becoming negative value, and that term is called deceleration. And don't forget the equation, my dear students. That is acceleration a is equal to v minus u by t. Hope you understood this topic. So dear students, hope you understood all the topics what we learned today. So in the next session, we will learn the remaining topic of this chapter. So I hope you understood all the concepts what we studied today. So in the next class, we will learn the remaining topic, that we will start from the speed time graph. Okay? So thank you. See you in the next session.